Hello guys. So I'll begin with the counting and combinatorics, that is permutations. So last video on this topic, review of the net part A, I covered question. I did some explaining of the permutations, combinations, that is arrangements and selections, and then an alternative method, that is counting. And we completed the third question, and then we were to move on to the next question, that is the fourth one. So kindly go through my first video on this. I'll move on to question 4. How many ways can you arrange 4 boys and 3 girls such that they are seated alternatively? So we have 4 boys and 3 girls, a total 7 chairs, you can say. Yeah, right? And to be seated alternatively. Now you'll have to begin with a boy, because boy, girl, boy, girl, boy, girl, and boy. So like that, 4 boys and girls will be covered. Hang on. So the question is there any other way we can have them seated alternatively so that they're seated alternatively? I don't think so. There's any other way, because if you have to go boy, girl, then that's the only way you can have an answer. So therefore, suppose there are 4 dashes for the 4 boys, then any of the 4 can be seated out here. So one of the boys takes the place on this dash. Then for the second dash, there are 3 choices because there are only 3 boys remaining. And then for the third one, there are only 2 boys remaining. And the last one, only 1 boy. So therefore, 4 factorial ways to arrange the boys. And similarly, 3 factorial ways to arrange the girls, because the girls have the 3 girls, and there are on the first dash, any of the 3 girls can come in. So there are 3 choices for the first dash. Then the girl takes the position out here. And for the second dash, only 2 girls are remaining. So there are 2 choices. And then finally, only 1 choice. So 4 factorial, 3 factorial ways to arrange 4 boys and 3 girls such that they are seated alternative. That's your answer. Question 5. How many ways to arrange 4 boys and 2 girls such that no 2 girls are together? Yeah. So there are 2 ways to solve this question. Yeah. So I'll show you the shortest method. So out here, what you do is you club the 2 girls together and make it 1 seat, like 1 dash. And the 4 boys, you leave them as it is, like 4 dashes for the 4 boys, and for the 2 girls, you're clubbing them together. So what we do is, for this question, we find out the number of ways we can arrange the 6 people, that is 4 boys and the 2 girls, such that the 2 girls are always together. Once we find out that once we find out that arrangement, then we subtract it from 6 factorial. By subtracting it from 6 factorial, because these 4 boys and 2 girls, that is 6 people, if we were to arrange them anyhow, without any restriction, without any condition, then there are 6 factorial ways to arrange them. However, when we put a restriction that, okay, the 2 girls should be together, then this is the restriction that we have, which means that there is 1 dash here and 4 dashes here, 5 factorial ways to arrange the 6 people so that the 2 girls are always together. And remember, these 2 girls, girl 1 and girl 2, can be interchanged among themselves, meaning they can change their position, meaning girl 2 can come here and girl 1 can come here. So therefore, you'll have to do into 2 factorial. Yeah. So therefore, when I subtract this answer 5 factorial into 2 factorial. That is 5 factorial into 2 factorial are the number of ways to arrange the 6 people so that the 2 girls are always together. When I subtract it from 6 factorial, what I'll get is the answer for the question out here to arrange 4 boys and 2 girls such that no 2 girls are together. So that's your answer basically, whatever it comes to. Now, you must be thinking, okay, what if we don't think that way? Fair enough. Then we go with the other method. So what is the other method? I'll just leave this over here like this. So the other method is you consider the 6 dashes first, like that. And then you find out the number of ways you can have the positions of 2 girls not together. Yeah, so you can have boy, girl, boy, girl, boy, boy. Yeah, 4 boys and 2 girls, right? Okay, so that's girl out here and here. Then you can have girl out here and here. So put another 2, 4, 6 dashes. And you can have the 2 girls out here like this. Correct? Not together. So whatever the answer for this will be the same one for this also. So out here it is 4 factorial for the 4 boys. Yeah, 4, 3, 2, 1 like that. And for the 2 girls it will be 2 factorial. Similarly, when the girl is out here and here, you'll have the same answer, 4 factorial into 2 factorial. And then you'll have to consider this position. You already considered this and this, this and this. So you'll have to consider starting from the third dash, this and this. Girl here and girl here. So again, 4 factorial into 2 factorial ways. Then you'll have to consider the fourth dash, because out here, fourth dash, meaning 1, 2, 3, 4, 5, 6. So from fourth and the last one like this. This also could be the girl's position. So another 4 factorial into 2 factorial. Now that was skipping one position between the 2 girls, meaning leaving one place between the 2 girls. Now we'll have to consider some extra, leaving 2 positions between the 2 girls. So like this girl and girl out here. Understood? So again, you'll have 4 factorial into 2 factorial. Then again, you put 6 dashes, and then you can have this and this, leaving 2 gaps. That's 4 factorial into 2 factorial. Now you'll have to leave 3 places between them. So 1, 2, 3, 4, 5, 6. So this and this. So again, you have 4 factorial into 2 factorial. Then again, you have leaving 3 positions from the second place onwards, this and this. Well, here and here. So that's again 4 factorial into 2 factorial. Okay, now you'll have to leave 4 positions, so that leaves you only with one choice. Yeah, that is these two. So that's 4 factorial into 2 factorial. That's about it. So just count 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 times 4 factorial into 2 factorial is 9 times 24 times 2. So that's 9 times 48. Yeah, fair enough. Maybe there is 10 times. Why? Because we forgot this first case. In the first case, the girl could be here and here also, no? Here and here. So girl and girl. That's another 4 factorial into 2. So it is 10 times. So the answer is 480. Now the short method out here, 6 factorial is 720. Yeah. Minus 5 factorial is 120 into 2. So that is 720 minus 240. And that is 680. Makes sense? The short method is much better because, like, if you see the longer method, I forgot the first dash, 6 G with G where the G is in the first place. So you could make an error. I knew the answer. That's why I remember. Okay, something is wrong, so first position should be taken into consideration. But yeah, I would never use the longer method because I'm bound to make an error. So that was it for the question number 5. Let's move on to question number 6. How many ways to arrange 4 chairs around a circular table? So that's another concept. So whenever you have arrangement in a circle, yeah. So imagine you have 4 people to be arranged on 4 chairs. So that's 4 factorial ways to arrange them. 4 options for the first one, third one. I mean, second chair, 3 options, and then 4, 3, 2, 1. So 4 factorial. Yeah, it goes left to right. But in a circle, we don't know the beginning. Like, what is the starting position? Out here, we know the starting position is the one on the left side. If you go from left to right horizontally. But in a circular way, we don't know the starting position. Suppose we say chair number 1, chair number 2, chair number 3, chair number 4. We don't know the starting position on a circle. So what we do is we fixate one position like this. So we know, okay, now from here, we go roundabout. So when we fix one position, yeah, so the answer then becomes n minus 1, the whole factorial. Usually it would have been n factorial. It was left to right. But in a circle, when we fix one position, so there's only one less than 4. That is 3 factorial ways to arrange them. Understood? One less, always one less factorial. Because you're fixating one position. So when you fixate one position, there is no arrangement for that position. The other 3 will have the arrangement. So that's basically 3 factorial ways to arrange them. Yeah. Okay. Great. So that was just one concept hardly asked at net level. Never seen any questions at net level. Arrange the letters of the word table. So that's the third concept of permutations, meaning permutations. There are several types of questions. The third type. So when you have to arrange 5 letters, TAPLE, how many ways to arrange them? There are just 5 factorial ways to arrange them because there are 5 letters. 1, 2, 3, 4, 5. How many ways to arrange the 5 letters? The first dash can have any of the 5 letters, 5 options. The second dash can have any of the remaining 4 letters. Third one, any of the remaining 3. Fourth option, remaining 2. And last dash will have any of the remaining 1 letter. Okay. So in the arrangement of letters, yeah, as you can see, once a letter is used, it's not repeated again. So 5 factorial ways to arrange letters of the word table. Okay. Now let's consider another question where letters in the word are repeating. Understood? So when you have a word like Google, where there are 2 G's and there are 2 O's, so first count the number of letters in the word. So there are 6 letters, so you say 6 factorial, and then divide that by the number of letters which are repeating. So 2 G's divide by 2 factorial and 2 O's divide by 2 factorial. So let me explain you why this division happens. I've already explained it in the previous video, but I'll explain it to you over here. So let's consider word Bob. Okay. Yeah, Bob. So let's put them all in small letters. Bob. Now this Bob, I can spell it in this manner, and then the Bob will come again because the arrangement of Bob is 3 factorial. Okay. So in this 3 factorial, imagine this is BA and BB. So then BB and BA comes. You see, it is actually Bob only, but it's just to show you the differentiation as to why BA and BB out here and the A and B are interchanged. Then you can have BA, BB, O. Yeah. And then BB, BA, O. Okay. And then you can have O, BA, BB. And then you can have O, BB, BA. So in a way, when you write 3 factorial for Bob, because there are 3 letters, you write 3 factorial, right? Just like Google, there are 6 letters, so I put 6 factorial. But eventually, what happens is there are the first two BOB and BOB are identical. And because they're identical, we need to remove that duplicity, right? We need to remove the repeating elements. So to remove them, we divided by 2 factorial. Understood? So when this 3 factorial is divided by 2 factorial because of the BB repeating, we end up getting only 3 ways of arranging the letters of the word Bob. Understood? Because of the repetition. Yeah. So out here there were 2 G's and 2 O's repeating, so that's how you put it. So let's take another example. Let's take where there are, it is Goodle, 3 O's. Now, because of this 3 O's, if you were to put it as OA, OB, OC, yeah, then these 3 O's would repeat 6 times. Like in the previous video, I'd explained ABC, ACB, BAC, BCA, CAB, CBA. So imagine these are all OAs, OBs, OCs, and OAs, OCs, OBs, and like that. These are all OOOs. So your Google, if you were to have it together, then you would have 6 Goodles. Goodle out here, Goodle out here, Goodle, 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 Goodle. So 6 times. So arrangement of this would have actually been number of letters are 7 divided by 3 factorial for the 3 O's, because all of these Goodles are one and the same thing. So in order to avoid the repetition, we divide by 3 factorial. Remember, not 3 factorial. Because it's 3 factorial is 6 times. It's repeating. It's coming 6 times. We need to count it only once. I hope you've understood this. Let's move on to the next question. Question number 9. Arrange the letters of the word boost. So that's just like, similar to Google or, boost is 5 letters. So 5 factorial ways to arrange them and 2 factorial for the repetition. 2 O's. Yeah. Moving on to question number 10. Arrange the letters of the word hospitality. So count the number of letters. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 factorial. And now count the repeating letters. So then repeating letters, I'll just use a different color. I have T. Use another color. I have I. And that's about it. 2 I's and 2 T's. None of the other letters are repeating. So double check and then that's it. So 11 factorial divided by 2 factorial for the 2 I's and 2 factorial for the 2 T's. Question number 11. Arrange the letters of the word table such that the vowels are together and the vowels are not together. So I just now explained you how to club things together. So A, E, I, O, U, these are the vowels. Okay. But in the word table, there are how many vowels? Only 2 vowels, A and E. So therefore, yeah, arrange the letters of the word table such that the vowels are together. So A and E we want together. So that's 1 dash you consider. And the remaining 3 letters, T, L, and B, T, L, and B, consider them as 3 dashes. So overall, there are how many dashes? There are 4 dashes. So 4 factorial ways to arrange them. And the A and E can be arranged among themselves. So that's 4 factorial and 2 factorial. Okay. So like you could have, for example, one of the arrangements would be AETBL and the other one would be EATBL. And like that, you'd have several such arrangements where the AE can come, in the like T is out here and AE is out here, BL, and then T and then EA and then BL. So like that. So there are 4 factorial ways to arrange these 4 dashes and into 2 factorial for the EA to be interchanged among themselves. So that's the answer for A. Vowels together. Vowels not together, right? So what I told you earlier, if you have to find out vowels are not together, then you first find out the answer for them being together and then subtract it from the total number of arrangements of the word table. So the total ways to arrange table is 5 factorial ways. You can arrange the 5 letters randomly anyhow. So 5 factorial ways, and if you subtract the number of ways to arrange the vowels together, If you subtract this, then you end up getting the answer for the second one. That is, the vowels are not together. Okay. Right. Let me check. Hang on. Wait a minute. Anyway, I don't know how much time has passed. 20 minutes. We'll move on to question number 12. Hang on. Arrange the letters of the word boost such that the vowels not together. Right. So boost. Yeah. First, we find out the ways to arrange the word boost so that the vowels are together. Correct. So boost, we club them as one dash. Yeah. And then for the S and T. So there are four dashes in together. So 4 factorial. Right. Yeah. Now the question is that the two O's, okay, the two O's are identical, right? Like in the previous case where we had table and the vowels are to be together, A and E. Just to show you A and E, when we arranged AE as one dash and TBL, so we could write it down as 4 factorial into 2 factorial because the A can be interchanged. But out here, if you interchange OA and put 2 factorial, then remember you'll have to also divide by 2 factorial because the word boost itself has a repetition of letters. Correct? So the what you end up getting is just 4 factorial ways to arrange the letters of the word boost because the two O's when interchanged, yeah, is just going to repeat the same word boost. So if you're going to multiply like into 2 factorial because of this funda A and E being interchanged, so O is being interchanged, then you also have to divide the entire arrangement by 2 factorial because of the repetition of O and O. So you end up getting 4 factorial ways to arrange the letters of the word boost, yeah, such that the vowels are together or such that, yeah, the vowels are together. Understood? Yeah. Now the question is, how many ways can you arrange the letters of the boost so that they are not together, vowels are not together? So how many ways can you arrange the letters of the word boost anyhow, without any restriction, without any condition? So there are 5 letters, so 5 factorial, and obviously you'll divide by 2 factorial because the two O's are there, and then you subtract 4 factorial from it. So that will give you the answer, yeah, to the number of arrangements of boost such that the vowels are not together. So this was a tricky question. Many could go wrong out here simply because they have probably mugged up this part, and which I don't blame. Once in my lifetime, also I've mugged it up. Yeah, but these concepts need to be understood. Double O's. So you'll have to, if you're multiplying by 2 factorial, then remember you're getting repetition. So you'll have to divide by 2 factorial because the two O's when interchanged are not giving you a different arrangement. They're going to give you an identical arrangement when you interchange the two O's. Unlike the table where A and E, if you interchanged, just give you a different arrangement, EATBL. That's how it begins, which is different from AETBL. And remember, in arrangements, the order is important. Yeah. So that's your answer. Question number 13. How many 4-digit passwords can you get from digits 0 to 9? So 4-digit passwords, put 4 dashes. And remember, passwords can begin with a 0. Yeah. So you can have 10 options here, 10 options here, 10 options here, and 10 options here because any of the digits 0 to 9, meaning any of the 10 digits can come in any of these 4 dashes. Because when you talk about passwords, we know that the digits can be repeated. So there are 10 raised to 4, meaning 10,000 ways to arrange, or 10,000 passwords that you can get, or 10,000 arrangements of 0 to 9. So the question is, what if it's a number? So I hope I have put that question in my handout out here. See, how many 4-digit numbers are there in the counting number system? So in the counting number system, you don't have a number beginning with 0. You have a number beginning with 1. Understood? So I could have probably rephrased this as how many 4-digit numbers are there in the natural number system. So natural number system begins with 1, right? So like that, uh, basically counting number system. So the first digit cannot be 0. Remember, right? The first digit cannot be 0. So you can have 9 options here, 1 to 9. Yeah. Okay. Because the digits are anyway 0 to 9. First digit cannot be 0. So there are 9 options here, but there are 10, 10, and 10 options for each of the remaining. So there are 9,000 4-digit numbers, and you can do it using common sense as well. Yeah. So if you know your counting system, the first 4-digit number is 1,000, and the last 4-digit number is 9,999. Yeah. And if you don't make the mistake of subtracting 1,000, because if you subtract 1,000, then you're getting rid of one of the 4-digit numbers, which is 1,000 itself. So always subtract one lesser. So you end up getting 9,000. Okay. So if you subtract 1,000, then remember you are deducting one 4-digit number, which is 1,000, when you subtract 1,000 from 990. So don't make that mistake. Question 50. A 4-digit area code cannot begin with a 0. How many distinct 4-digit area codes can we get? So there's a 4-digit area code and it cannot begin with a 0. So how many distinct 4-digit area codes can we get? So if it cannot begin with a 0, then you have 9 options for the first one, and you have 10 and 10 for the remaining 3 digits. So the distinct 4-digit area codes is again 9,000 out here. Got it? Yeah. Okay. Going on to question number 16. A 4-digit area code cannot begin with a 0. How many distinct 4-digit area codes can we get if the digits once used cannot be repeated? Now, out here, you cannot have the digit once used repeated. So put 4 dashes first. You know, it cannot begin with a 0. So there are 9 options here. Yeah, 1 to 9. So remember, the digits are 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. So 0 is not there in the first position. It cannot begin with a 0. So there are 9 options, 1 to 9. Now, from 9 options, 1 to 9, if one of the digits is used, you cannot repeat it again. So therefore, for the second one, yeah, you cannot repeat one of the digits. So let's say the one of the digits that you've used is 1, for example. So then you can have 2, 3, 4, 5, 6, 7, 8, 9, which is 8 digits plus 0. Now 0 can come here. So 9 digits out here. Understood? So 0 is included in the 9 digits. Okay, right. Now the third option, now remember you've already taken 1 digit out here and you've already taken 1 digit out here. Correct? So then there are 8 digits remaining. All right. 8 digits remaining. Because now from starting from here, you have 9 options. Correct? One of the digit goes. These 9 options are including the 0. These 9 options are excluding the 0. So now you have 8 and then you have 7 options. Slightly tricky, this one. Okay. So in the first one, remember you cannot take 0, therefore you have 9 options. In the second one, yeah, you are including the 0, therefore you have 9 options. So ideally, in the second one, you would have 8 options, but then you can include the 0, therefore 9 options. In the third one, you don't care about whether it is 0 or non-zero, because we know that we have to get rid of the 2 digits which came here. So in the third one, it is 8 options. Now these 8 options could be 0, could not be 0. It all depends upon whether the 0 came in here or no. Whether 0 came in here or no. So it just doesn't matter. You don't have to think that way. Just remember 8 options here and then 7 options here. So whatever the answer out here, multiply it. Got it? Yeah. Okay. Moving on. Question 17. So this is a counting question. Yeah. 18 and then 19, 20. Are there more? Okay, there are 20 questions in total, starting with the 17th one. Okay. There are X people. There are X people in a line at a ticket counter. Harry stood a few people before Tom. So Harry stood a few people before Tom. So there are a few people out here. And he stood a few people before Tom. Yeah. So remember, imagine this is a ticket counter. Yeah. And the line begins from here. Okay. So Harry is in the line and Harry stood a few people before Tom. And why people stood before Harry? And why people stood before Harry? Okay. If there are P people after Tom, now there are P people after Tom. Yeah. P people after Tom. Then which of the following would give the correct algebraic sum of people who stood in line between Harry and Tom? Assume nobody entered or left the line. Now remember the starting point, there are X people. So when there are X people and you have to find out how many stood between Harry and Tom, then first of all, you're going to take X people and subtract the Y people which are before Harry, P people before after Tom, and then you subtract the two people which are Harry and Tom. And that way you'll get the remaining people between Harry and Tom. A very simple question. Total X, subtract Y, then subtract P, and then subtract Harry and Tom, which is 2. So whatever remains is between Harry and Tom. Got it? So your answer option D is your answer. Got it? It's a counting question. Okay. Now remember, guys, in counting question there are many things that you can learn. Yeah, but try to try to um, try to understand the pattern as you go. Do not um, kind of learn things in advance. Do not mug up things in advance. For example, okay, let's say that roll number 34 to 97. Roll number 34 to 97. How many students are there from roll number 34 to 97? How many students are there from roll number 34 to 97 from? So what you do is you take 97 and subtract 33 from it. Okay, because you have to include 34 and 97. Okay, now whenever you don't understand these things, take a smaller set like 1, 2, 3, 4, 5. Okay, and 6. Take. So if you were to consider roll number 2 to 6, from 2 to 6, there are how many students? Correct. So we know 2 to 6, we can count there are 5 students. 1, 2, 3, 4, 5, 6, there are 5 students. So if you were to do 6 minus 2, then you end up getting a wrong answer. You see, 4 you're getting. So you can always take a smaller set and figure out what needs to be done with 34 to 97, then waste time, So we know that 6 minus 1 is to be done. So similarly, 97 minus 33 will end up getting your answer, which is 50, 60, 64. 64 students, sir. Got it? And similarly, if the question was, yeah, I'll just leave it out here so that you can look at it. Roll number between roll number 34 to 97, there are how many students between 34 to 97? So between 34 and 97, you cannot include 34 and 97. So then again, if you were to do 97 minus something, yeah. So think again, if I were to say between 1 to 6, I know there are 4 students, 1 to 6, 2, 3, 4, 5. So how do I solve this question? Yeah, 2, 3, 4, 5. So should I take 6 minus 2 and all that? Yeah. So what you simply do is, yeah, you know that you want to get rid of 97 and 34. You know that if you were to do 97, if you were to do 6 minus 2, like in this case, 6 minus 2, then you're getting rid of, 2. Understood? You're getting rid of 2. But in this 4, yeah, in this 4, you have So for example, let me take another situation, 1, 2, 3, 4. Yeah. Now, if you were to do 6 minus 1, because I'm asking you between 1 to 6. I know the answer is 2, 3, 4, 5, 4 students. So if I were to do 6 minus 1, I end up getting 5. All right. Now I know that 6 minus 1, all right, is 5. So I've included 2, 3, 4, 5. I need to get the sixth one out of the picture, therefore minus 1. Okay. So from 34 to 97, between 34 to 97, if I subtract 34, right, then I know that I've got rid of 34 by subtracting 34 from 97. That is, I'm getting 63 out here. But from the 63, I need to also get rid of the 97th number. So subtract one more. So I end up getting 62. So between 97. So do not mug up these things. Yeah. Then there are other things also. For example, consider the the bars hand, the clock, the analog clock. Yeah. Analog clock where you have markings, tick marks at 12, at 1. Yeah. So analog clock where you have 12, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, like that. So if they were to ask you in a circle of an analog clock, yeah, there are 12 markings, 1 to 12. Okay. Then there are how many spaces in between them? So just remember there are 12 spaces in between them. Okay. But if they were to say there are these logs, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. And now they ask you there are how many spaces in between them, then there'll be one less than the 12 logs which are there. All right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So these things also, like I said, don't mug it up. Take a smaller set and figure out. Okay. So instead of having 12, just take, okay, if I took 4 slots, like that. So how many gaps are there? 1, 2, 3, 4. Like that, you figure it out for the bigger numbers. Not necessarily they'll give you a clock. Okay, they can give you anything. Not necessarily they'll give you something like 12 logs. They can give you like 5 logs. So 5 logs, 1, 2, 3, 4, 5. How many spaces are there? 4 spaces, always one less. So understand these patterns. Anyway, going on to question number 18. Right. I think I'm going to stop here. The video has just gone longer, so I'm going to stop here, and I'll complete my questions 18, 19, and 20. Yeah. In my next session, how many selections of a team of 4 can. Okay. In the meantime, if you have any questions, you can post it so I can also discuss this, because the next video might be just a 10-minute video. Anyway, thank you.